Hello everyone, so today we are going to solve a partition into minimum number of Deci-binary numbers. So here we have been given like what is a decimal number and what is a binary number. So binary number is a number without any leading zeros and which contains only ones and zeros. So we have been given a positive integer like this, and we want to say that how many like binary numbers are required. So let's say 10 is a Deci-binary number, and if we add 10 to 11, it will give us 21, and if we add 21 to 11, that will give us 32. So we want to know that what is the minimum number of this Deci-binary numbers that we should have to give this output, give the given number of output. So before we solve this, this is a medium level LEET code problem. You can find it on LEET code. I'll put the question link in the description. So now let's try to understand the question. So the thing is that we have been given, now let's say I have a number like 333. So in this, anyone can easily tell that if we add 111 plus 111 plus 111, this will give me 333. This all three of them are Deci-binary numbers. Now let's say I decrease one value, any value. Let's say I made it 233. This I can like again find a Deci-binary numbers. Again the like total Deci-binary numbers are going to be 3. Because I have decreased one value of 3, I have to decrease any one value of I have to decrease one value of any of these 3 Deci-binary numbers. Let's say I select the middle one. So this will become 111 plus 011 plus 111. This will again give me 233. This is again like 3 numbers are required to make this Deci-binary number. Again, if we try to like reduce 2 of these values again, this will give me 33. In that case, I can make it something like this. Again, our answer is same. Total number of Deci-binary numbers are 3. So the thing is that we notice here is that let's say I have a number 192. In this, the biggest number is this number 9. That means that how many numbers I have, how many Deci-binary numbers I have, I should have 1 in the second place at least 9 times, or else there is no way to make this 9. So I have to make this one at least 9 times, and besides this I have to make this one like at the first place. I have to make one at at a maximum of 1 time, at maximum and at least. So I have to make a total of 1 times this one as well. So I can like place this one anywhere in this 9 numbers. I already have decided that I have to make 9 numbers who has 1 in their second places. In them, in those 9 numbers, I can place this one anywhere, and also I have to place 2 ones. So I can place these 2 ones anywhere in this 9 numbers. So it is easy to claim that the answer is going to depend on the number, like the single number which is like largest in the whole number. So if I had 1, 2, 3, 8, 5, in this, by looking at this string, I can tell that my answer is going to be 8, because I need a total of 8 digits, 8 Deci-binary numbers to cover this up, because we can only take zeros and ones, and a possible way to get 8 by adding 1, 1, 1 is like adding 1, 1, 1 8 times. That's why this is our answer. So how can we do this? So we have seen that we need the maximum of the digit. So here maximum is 8. Let's look at sample input as well. In this, maximum was 3, so our output was 3. In this, the maximum, like the number was 8, so our output was 8. So I have like written a simple formula to like solve this question. First I have an integer answer which will store our answer, and then like I'm looping over the string. I'm like finding the value of string in integer. So let's say I have any character, so those characters are going to be in between 0 to 9. Those characters are going to be in between 0 to 9. So if I write something like this, 0 minus 0, this will give me 0. And if I write something like this, 9 minus 0, this is going to give me 9. So these are like, I'm converting these characters into a number using the ASCII values of those. So what this is going to do is, this is going to convert 9 into ASCII value, this is going to convert 0 into ASCII value, and this is going to subtract it then. And if you look at ASCII table as well, the difference between the character 9 and character 0 is a total of 9. That's why I am doing this, and this is giving me the integer x, this is giving me the value of this character in integer, and then I am storing the maximum of those, and at the end I am just returning it. And if you try to submit it, this will run as well. So yeah, this is it. And total time complexity is big O of like the string length, big O of and the string length. And if you look at constraints as well, like 10 to the power 5, we are solving this question in big O of 10 to the power 5, and that well suits in our constraints, so we don't have any issue there. So I hope you have understood this solution. So if you have any doubt, please feel free to write it in comments.